Here we go. Excellent. So, hello everyone. In the next 10 minutes or so, I'm going to explain what are data catalogs and why they make building AI faster and more cost efficient. I'm Vili Hätönen. I work as a data scientist in Emblica. And for the past year, I have been working with mostly deep neural networks with our customers and a couple projects going to pending patents at the moment. Emblica, we are a small data engineering company based in Helsinki. And we work with public sector, private sector, small, big companies, mostly doing research and development, like in this picture with Caruna. And then we have longer partnerships for data analytics, for example, with Sanoma, and then research and development with Uponor, and many other projects that I don't have time now to go into. Before going to data catalogs, I would like to really briefly take you to an imaginary restaurant. Imagine that your friend asks you to go to a fancy new restaurant. You arrive to the place and you sit down, and your friend asks you right away that, what are you going to order? No menus, no waiters, no personnel whatsoever inside, and you have never been to this new place. You have no clue that would they even offer. How would you choose what to order in that kind of situation? This reminds actually a lot of a start of a new AI project these days. The expectation is that, we are going to do this really cool thing that is going to have a lot of business value and impact, and we're going to bundle with all these cool AI technologies. But what ends up happening is that you spend weeks or even a month, your head in a bucket, trying to find the data, make sure that it's high quality, find out that who owns it, and so on. This problem is something that can be solved with data catalogs. But before going there, really briefly defining what is AI, because it can mean a lot of things for different people. For me, artificial intelligence is automated decision making. It's a one step forward in the path of automation and to tasks that previously we humans needed to make a decision on. What kind of plant is this? What animal is this? How much biomass is in this lake given this image? These kind of decisions were made by humans, and now you can outsource them to AI with these cool machine learning technologies that we can implement. Well, if you want to develop such a system, then what kind of data do I need, or what kind of requirements I do have for my data? Well, it boils down to four things. First of all, you need to know what's out there. You need to know that what kind of data sets or assets are available in the organization you're working with. Second thing is that you need to know how the data is gathered and processed, because certain kind of gathering or processing might introduce bias into the data, or otherwise you might not even know that what the data actually compasses, like has inside of it. The third thing, you want to have high quality data. If you put low quality data to your machine learning model, you're going to have a poor model. That's it. You want to know if all the fields are there, if there is a measurement error in the data a lot, that kind of thing. So the fourth thing is that you want to know if your data set is related to others. If there is a lot of cross dependencies between data sets, that would be really neat to know at the moment when you're kind of finding out that what data are you going to train your models on. Well, the reality is that the current data platforms don't always answer these needs really well. And to explain why, I'm going to walk you really fastly through data platforms, 3 generations of them. Starting from the 90s, you have data silos or data warehouses, where you have individual teams owning their data, but keeping everything inside. If you wanted to get access to, marketing team's data, there was no way, because there was no interface between the two. Everything was in silos. Well, this was solved by data lakes or other big data platforms, bringing the data into one place so it would be accessible for everyone. The problem is that now you have one really specialized data science team that answers the data needs of all different teams and sub-organizations. And poorly managed data lake can become a data swamp. At the 2020, you're at the moment when you come back to distribute things out a little bit more so that you have individual teams that serve their data that they work with, but they serve it as a product to other teams to use. And here, the data catalogs come into play. I'm not going to tell, okay, really briefly, I'm going to tell what data catalogs are. They are inventory to all data assets in an organization. It's much more efficient that I show you what this would actually mean in practice. Let's say that I want to model physical collisions of particles. Here, CERN has a lot of data on it, and they have made it available like this. So you can start to search that, okay, I want to model with collision data sets. Well, okay, that's quite a lot of data sets, but actually I'm only interested in the ones that have supplementaries with triggers, and they were done during year 2011 because for some reason it's really interesting. And then, this particular photon data set seems quite cool. And here I can find all the metadata, all the information relevant to it, and even how can I access it and how can I use it. So this, in essence, is one thing that you can solve with data catalog. Now, going back to the restaurant, where the meals that you wanted to order, those are the data assets. You don't even know what they are if no one's there to tell you. So in this comparison, the data catalog is the most professional waitress there is. She has all the answers for you that you want to know. What kind of meals or data assets are there? How were they produced? How were they processed? Is there anything that you would be allergic to in this particular data asset? She can provide you the answers, and the data catalog can provide you about the organization's data in a nutshell. You don't need to believe me that this is a big thing. This year, Google, Amazon, Microsoft, and some others launched their data catalogs to a big scale. And then since 2016, there has been many companies doing like a data catalog in-house. For example, Twitter blog posted about it 2016. And some of these solutions have become an open source project. For example, the Amundsen project is open source, available on GitHub. So if your organization wants to start to use data catalog to better find and manage your data, then this is one way to start. Another way is that you start to build things completely fresh in-house, which is what we did at Emblica. How our data mesh differs from the Google and Amazon's. We do, because our clients are from have all kinds of different cloud solutions, then our system works with all of them. But one data catalog there, one there. The main point is the same: to find and manage and discover and understand data better. So going back to the AI, if these are the needs that you have for developing a good AI system, usually implemented with machine learning, then data catalog can make it much faster to get from the idea to the actually implemented product when you find and manage the data better. Thank you really much. I think that was more or less 10 minutes.
Very nicely managed with time, and a great presentation. I haven't yet seen any direct questions to you, but would be really happy to see questions also from the audience. But I actually have a question that is bugging many of our clients who are more concerned with mostly the data value. I understand you talk about the quality of data and what data exists. Does your process and does your way of looking at data repositories have a way of looking at also the data value? Because usually kind of getting to the data has a cost. Building the integration, building a way of understanding and looking at the data has a definite cost, which needs to be offset by the benefit. How do you deal with this cost-benefit question in this?
Thank you really much, Reko. That was a good question. In two ways, this kind of a data catalog tries to affect both sides of the equation. So it tries to make the cost lower by making everything much more accessible. So in your organization, if you want to start a new project, you don't need to find necessarily, the person and ask the question directly from him or her, and then they will tell you someone else that actually manages the data set, and then you organize a meeting, and then you start to look all the access rights. With data catalog, you can skip this step and right away find all kind of options that you have and therefore make the cost much lower. And about the value, if you do this right, you can actually model the business concepts alongside the data. So instead of just looking at the database rows and the actual technical information, if you do this in a clever way, you can start to model the business concepts that the data is related to. So then you have the mapping from upside that, okay, what kind of data exists related to our users? What kind of data exists related to our certain product? And is there perhaps, if we want to model something regarding this product, what kind of data is there? Where are they located? Who do I need to contact to? And this kind of thing could be done with data catalogs.
Really good. Thank you. We have a question actually, and we even have time for it, by Michael Kobold. And his question was, how is the catalog organized? Is it organized by data type, by processes, or by topic, for example, accounting, purchasing? And how is maybe this, continuing on his question, how is this decision made on the structure and organization?
Thank you, Michael. I believe that it depends all on the implementation of the catalog. I don't see any reason why you couldn't choose on the fly that by how you organize it. So how this in practice is implemented is that you have all your data assets spread to different organizations. Then you have metadata crawlers that are going to collect metadata about these data sources. And this metadata is brought to the center to the catalog. So now by looking from the catalog, of course, you can organize the information by the data types. Is it like a stream, a database, endpoint, or some other kind of source? Or then maybe you can also model the processes that, okay, this data set came from there, it is related to here, do some kind of lineage between those. I hope that this answers the question somehow.
I think it did. I think it did. Of course, there are then related to that, especially in my experience, is then that the metadata is often very patchy, and it might not be correct. And
Yes.
and that then becomes the next question: how do you fix that?
We have went for this kind of wiki style editing. So the robots can do some work for us. Even though there wouldn't be some metadata filled by humans, we can train a model or just like organize the crawlers in such a way that they compile to you that how much, what type of data, what kind of fields, whatever. But then we can also do some kind of editing of human-made descriptions. So let's say that there is another organization that hasn't really handled their metadata descriptions well, but you use one of their data sets. Maybe you can then write the description better after you worked with the data set, instead of, if they don't manage their data properly.
Excellent. Thanks so much, Vili. That was really, really insightful.
Thank you very much. I'm going to tune in for the other talks.
Very good. Excellent. Thanks, Vili. And next